This is our project, a canvas-based system for monitoring and fault diagnosis in wind turbine. VA Prithviraj G. Saradi and C. Srinath had done this project. So, what we are going to, what we had done here is, we are just monitoring and diagnose the fault automatically in wind turbine. So, in an existing system, what they will do is, they are monitor the fault which will be occur in wind turbine in manual process, just like we have to go to the center side, that means to wind turbine, and we have to find where the fault occurred, and then we take steps to for diagnose the fault in manual process only. So we are totally reducing the time and also power consumption by giving this an automatic process using a CAN protocol. So using CAN protocol, we are automatically monitor diagnose the fault and monitor the processes. Okay, so just go with our kit. So this is our kit. Here this is a transmitter side and this is our receiver side. So this is a CAN protocol, this is CAN transmitter, and this is CAN receiver. So here we are taking 230 volt as a input. So once we give an wind turbine, there will be some instant voltage input as a input voltage. So for that, in this project we are taking 230 volt as a normal voltage. 230 we are taking. So which will be directly not given to arm and CAN, because it will burst at a high voltage. So we are giving this 230 volts to a capacitors and to a rectifiers. So once it will given to a capacitors, means it will reduce the sum of amount of voltage, and then it will due to rectifiers. So rectifier in the sense, two rectifiers we are using, one small rectifier and one high rectifier, a big rectifier. So this small rectifier will give you a 3.5 volt, and this big rectifier will give you 5 volt. So why we are using these two rectifiers? For ARM processor, here we are using the type LPC2148 ARM processor, so which will operate at 3.5 volt, and our CAN proto transmitter and CAN receiver, the CAN bus connection, which will be operated at 5 volt. So that's why we are using two rectifiers. One will produce 3.5 volt and another rectifier will produce 5 volt. So this small rectifier will give 3.5 volt to operate this ARM LPC2148, and also this receiver side ARM side same LPC2148, and this 5 volt will operate for this CAN protocol. That means this CAN bus will operate only at 5 volt. So just we go with the process. First of all, we have to give this voltage 3.5 volt to ARM7 processor. Once ARM7 processor starts its process, means we are connecting, that means this is the transmitter side. We have to see this as a wind turbine side. So this in wind turbine side, we are connecting these sensors. We are connected the external factors which will often affect our wind turbine. The external factors are our temperature increasing, due to increasing of our temperature, and any vibration. If you increase the vibration, means it will have one effect. And also we are having we are looking for a voltage, increasing voltage. These are the factors which will mostly affect wind turbine. So we are taking this sensing these factors continuously using sensors, separate sensors for temperature measurement and our rotation, wind turbine rotation measurement, and also our temperature and this voltage measurement. So we are using separate sensors for each factors, and we are sensing continuously. So once any of the factor will increase, means we are monitoring in receiver side. So this monitor will give you the amount. If increase, means we can see from our receiver side itself. That mean our center, that mean our receiver side, control center itself. So on we are using automatic diagnosis. So how we are going to diagnose the problem automatically? So if increase the temperature increases, means we are having a cooler. So once the temperature increases, the buffer will start, and once the buffer will start, means that we are connected one cooler in receiver side. So this cooler will automatically turn on, and this cooler will turn on, means the temperature will totally getting reduced. Okay, so this is what the fault will diagnose automatically. So and we go with our voltage increasing, and also our vibration level increasing. So once vibration level increases, means the buffer sound will activated, and we are using one relay circuit. relay circuit, why we are using going for relay circuit means relay circuit will disconnect any of one connection in our receiver in our wind turbine. So if any connections will disconnected using relay circuit means the process will get slow down, and within a second or a minute the process will get stopped, so the fault going to occur will be stopped. So that's why we are using relay circuit. Once we are if the vibration increases means relay circuit will turn on. Okay, and for voltage increasing and also for wind speed, for those things we are monitor the fault, we are monitor the amount in our receiver side. So this is what our project, almost this is the matter we are doing here. So we go with the practical session. Just we are giving a 230 volt connection, and just on the transmitter side and receiver side. So this 230 volt converted by using rectifier as a 5 volt and 3.5 volt. Once the 3.5 volt will come under means, so here is the receiver side, we are monitoring continuously in receiver side, that means our control center side. So see, amounts are coming. This is the initial amount we are having, like 318 temperature is increasing, it's going just a manual side, and 270 wind speed, like that it is initial. So once if we increase the temperature, that means this what vibration level, vibrating sensor. So this vibration sensor we are giving more vibration means buffer will um, buffer will make a sound. So we can identify there will be a problem, and also you can know where the problem, why the problem occurred and where the problem occurred using this monitor. So if we increase the vibration means the vibrating speed will be increased in our monitor side, so we can easily identify where the problem is occurring and why, what is the reason, by seeing this display, because the wind speed, that means sorry, our vibration speed will increase, dB level will increase, so we can identify due to high vibration the problem will occur, and the buffer will make a sound, so the process will get shut down by using, already said the already told you that relay circuit, using this relay circuit we are using just for disconnecting any of the connection in wind turbine. So this is for this is like for wind turbine using MEMS sensor. So for vibration sensor we are using MEMS, that means micro electromechanical sensor. Okay, next we had another sensors for wind speed and for voltage level. Wind speed in the sense, if we increase the wind speed and also we can reduce this wind speed, we can note the values here. So wind speed, for wind speed there is no buffering sounds because we are monitoring only, because wind speed is not a constant one, it will be increasing at most any level, so we are not having any automatic diagnosing level, automatic diagnosing method. We are easily monitor the problem wind speed, because wind speed is not a constant one. So this is what our project, totally this is what our project. If we increase the temperature using any external factors, that using temperature increases means the cooler will automatically turn on, the cooler will automatically turn on, and the cooler will run up, so the uh, wind turbine get cooled and the problem is getting reduced. So go with project, with our project means, once the ARM processor LPC2148 on turned on using 3.5 volt means the process will start. So process will start in the sense how it will sense all the factors, and it's continuously sending the matter, we're sensing value to the receiver. So how it is sensing, it is sensing using CAN protocol. So how you know about this process is going on, using this light. So this light is blinking always, see, this light will blink always, this light will blink while the process is on process, while it is in process this light will blink, see, it is blinking. Now it's blinking means there will be a process between transmitter and receiver, so can transmitter and receiver, so the light is blinking. If there is no transmission between this means the light will not blink, the light is just for intimating, just intimating us where the process is going on. So you are not supposed to turn off, or you are not supposed to do anything with CAN protocol. So this is what our project, and here are going means these are relay circuit, and this what another rectifier circuits we are using for rectifying our problems. So this is what our project, and it is for RPM counting circuit. So RPM will increases means the buffer will automatically notify us using a buffer sound. Okay, and thank you, that's our project.